Okay, to make 51 easier, I'm just going to draw myself a little sketch of negative x squared. That should be a basic graph that you have memorized. So the maximum occurs here at 0, 0 at the origin. So the increasing intervals is for every x less than 0. When you read your graph left to right, this is the part that's increasing. So we use this symbol for the inequality. I don't want you to think that's or equals. So the x values that graph is increasing is for x less than 0. Okay, for 52, we have right end behavior and left end behavior. As x goes to infinity, f of x goes to, and then for left, that's as x goes to negative infinity. So since 52 is an odd degree, positive leading coefficient, I'm going to base that off of the graph y equals x. So as we go to the right, y goes to infinity, and as we go to the left, y goes to negative infinity. Okay, similarly for 53, right and left end behavior. It's the same setup every time, but now we've got an even degree of 4 and a negative leading coefficient, so that's similar to a negative x squared graph where both end behaviors are negative infinity. Okay, so this is somewhat of a repeat question. So for right and left, as x goes to infinity, y goes to, x goes to negative infinity, y goes to. Okay, so for a positive leading coefficient even, that's similar to x squared, so both answers will be infinity. For b, when it is a positive leading coefficient but odd degree, that's similar to a positive slope line. So to the right is infinity and the left is negative infinity. For negative leading coefficient, even degree, that's an upside down, similar to an upside down parabola, so both end behaviors are negative infinity. And then last but not least, an odd degree with negative leading coefficient is a negative slope. So that means the right end behavior is negative infinity and the left is positive. Okay, so now for 55 and 56, what is really nice is they say write your polynomial in factored form. So I don't have to multiply it to standard form. But what we have to take into account is I don't know the leading coefficient. So I'm going to leave an a in the spot for whatever the leading coefficient may be. Now we can see all the x-intercepts on the graph. So they're going to give us our factors. X minus negative 2, x minus 3, and x minus 6. Now the same thing for 56. But what I can tell for 56 is based on the end behaviors, it's going to be a negative leading coefficient. So when I hold the spot, I'm going to write a negative a. X minus negative 5, x minus 0 is just x, and then x minus 4. So 57 and 58 for the factoring. These are sum and differences of cubes. So that is a factoring pattern you are supposed to memorize. Here's the pattern. Same, opposite, always positive for 57. 58, because it starts as plus, would be same, opposite, always positive. So for 57, what times itself 3 times is 373. I'm sorry, 343 is 7, and then x cubed. And 5 times 5 times 5 is 125. So 7x squared is 49x squared, 7x times 5, and 5 squared. Same, opposite, always positive. And for 58, it's going to be x and 4, x times x, 4 times x, 4 times 4. Same, opposite, always positive. For 59 and 60, they say find all zeros, not just real zeros. So technically, it says you can use your calculator. However, you'll only be able to see the real zeros when you use your calculator. If you factored these sums and difference of cubes, the trinomial, when you factor, is going to give you two imaginary solutions. Therefore, you wouldn't be able to see them on your graph, and it really would just be a waste of time because the only zero you're going to see on your graph is 2/5. But we need all zeros, so we also need to include the imaginary ones. For the trinomial, I'm not going to complete the square because of the 25 and the 10, so we can do quadratic formula. I guess a calculator would be handy for some of the arithmetic here. That's b squared minus 4ac all over 2a. Okay, so what is this? This is 100 times 4, so this is 400. 100 minus 400 is negative 300. We'll be able to simplify that square root. So that's x equals negative 10 plus or minus. Now 300 is 3 times 100, and the square root of 100 is 10. So this is 10i root 3 all over 50. Now the numerator has a greatest common factor of 10. And the reason I want to factor it out is because the 10 and the 50 can simplify. So 1 0 is 2/5, and the other two zeros are negative 1 plus or minus, oops, I forgot the minus there, I root 3 divided by 5. So now for 60, it's very similar. We're going to factor it. Same, opposite, always positive. So for the first factor equals 0, that's our real 0. We get negative 3/4. And for the trinomial, again, I'm not going to complete the square because the leading coefficient is 16, and then b is negative 12. So I'm just going to do quadratic formula again. Negative b plus or minus the square root of b squared minus 4ac all over 2a. So then we simplify this. And 4 times 16 times 9, that's 576. And we take that away from 144, we're left with negative 432. So to simplify 432, that's 16 times 27. And 27 is 9 times 3, so I actually have two perfect squares here. The square root of 16 is 4, and the square root of 9 is 3, so that's 12i. Can't forget the I. Root 3 all over 32. We can factor out a 12 from the numerator. Oh, plus or minus. And then 32 and 12 both reduce. We can divide both of those by 4, and we're left with 3 times 1 plus or minus I root 3 over 8. Now to finalize that 0, what I'm going to do is distribute that 3 back into, so the other zeros are 3 plus or minus 3i root 3 all over 8.